it is time to welcome, highlight, and acknowledge the winner of our innovative and successful Searching for the Next Einstein online campaign. In February, CFHU launched a web-based contest looking for the most innovative and creative idea of how to improve the world. A panel of judges, including a Hebrew University Nobel laureate, Hebrew University scholars and scientists with equal voting weight from the general public, who could also vote for the best idea, chose Charles Rose from London, Ontario, as the winner for this big idea of photosynthetic dragonflies. And the best part, for those of us who are over 50, is that Charles, who you're going to meet, is now 70 years old, which means that creative ideas are not only the domain of the younger generation. Charles grew up in Buenos Aires and studied medicine and physics at the University of Buenos Aires. After several years as a general surgeon, Charles moved to Canada in 1979 and ultimately became a research associate at the Department of Pathology at the University of Western Ontario. His third career was as a high school science teacher. And who knows what his fourth career might be after winning this contest, which included this trip to Israel, $10,000, and the opportunity to share his idea with the media.
Thank you very much. I am very honored to be here, and it is a privilege for me to address this great audience. I will be very brief, because the subject itself is involved and there is no point in dealing with details. So I wrote a couple of notes. First is, what's the point of this? Well, the Industrial Revolution basically not only brought technological advance, but also reliance on fossil fuel. And that implies CO2. Everybody is aware there is a factor for global warming. A quick look at Venus will convince you of the effects of CO2. Now, we all remember photosynthesis from our school days, and this is essentially a process in which the energy from the sunlight, is harvested by plant cells and algae, and it captures CO2. The end product is sugars. This process takes place in an organelle inside the cell called the chloroplast. That is a fantastic feat that only nature can do that. So far, no artificial system has ever been able to duplicate natural photosynthesis. How could I combine photosynthesis and an astounding insect called the dragonfly? In other words, how could I make a photosynthetic dragonfly? Well, why a dragonfly? The dragonfly is a good choice because it likes to eat mosquito larvae and flies. Everybody knows that both mosquitoes and flies are vectors for human diseases. On the other hand, the dragonfly itself is harmless to humans. It doesn't bite, doesn't sting, doesn't do anything, and it's not a vector for diseases. It doesn't affect agriculture, doesn't affect farm animals. It's perfect. So if we could make a dragonfly photosynthetic, then it could be a step in the right direction. Current techniques in biotechnology certainly allows us to do that. Of course, we need to make large amounts of photosynthetic dragonflies, but they can certainly contribute to the capture of CO2. So to summarize, the point is to make photosynthetic dragonflies that can capture CO2 from the atmosphere and via photosynthesis convert that into sugar that the dragonfly can use for its own benefit. Thank you very much.